Shall we start?
Who's the chair? I think Matt, you are
That
supposed to.
Let's get started. Seong-Jin Kim.
So hi, good morning everyone. It's very nice to see you. I am Seong-Jin Kim, postdoc fellow here working with Tomo. Preparing this conference, I was really looking forward to seeing you guys. So thank you so much for participating. Without this, it couldn't have been possible to get to this place, right? So I really appreciate this. And I hope you could also give a very nice talk and presentation. So welcome to this meeting, and also food. So today I'm going to give you a brief summary about the data. But most of all, I would like to describe some more about the
Do you hear okay in the back, or should we use microphone?
I think I need to use microphone.
Is it okay?
Is it okay?
Yeah.
So today I'm going to give a summary about the data. So is it
Okay. Better with microphone without.
But I think that for the remote people.
That's true. That's true.
So I'd like to
The wire just keep going.
So I'd like to describe some more about the current status of the source matching and band merging in our NEP field. So Nagisa and me have been working on this for several months, right? So I think it's just about to finish this, right?
She's nodding.
Yeah. So this talk is going to be like progress report, I think, and I think you may be able to see the final version of Bender's catalog maybe next week, hopefully. So I'm going to start with a brief summary of the data. So the north ecliptic pole field is one of the most frequently observed area in the sky. So we have extensive data set from UV to radio bands. So especially Akari Space Telescope observed 5.4 scale degrees around the north ecliptic pole as one of the larger solar emission. As shown here, these green boxes show that a lot of pointed observations were combined and mosaic together in order to cover this whole wide area. And recently, this 5.4 scale degree is completely covered by the slower HEC data using these 5 GRIGY filters. And this is the map. And the whole data is composed of actually small patch areas. So this NEP, Akari NEP wider field is a gray shaded area here behind these boxes. And these, all these small boxes are actually patches. And yellow, green, pink, these are different colors. The 7 different colors represent 7 different fields, so-called tracks. So this small HEC data can be referred to based on the track patch numbers. So actually, we've gotten over many issues and problems so far, and now this data became available actually. So I think it's the right time to make a brand new optical identification and get a new band merged data and catalog. So besides that, we also have optical and near-infrared ancillary data obtained by various ground-based observations. For example, central 2 scale degree was covered by CFHC megacam, and the outer field was covered by Maidana observations. And Flamingo JH band observation covered the entire NEP wide area, and additional U band and a little bit more deeper data over the Akari NEP deep field here. So UHC data looks like this. The first panel and middle panel is kind of color composite images made using by GRI band and IGY band. And this is Akari N2 band image. So compared to the previous CFHT image, it looks much better, right? Because it is 2 magnitude deeper in G band and 1.5 magnitude deeper in R band. So it looks much better, right? For example, the background is a little bit noisier, and there is an observable gap between the frames. So it's actually much better. So we also the wide and speech covered this area, but mostly by the near infrared band. And COSEL also finished its NEP survey as one of the open time program using these 3 bands of Spire, and observed 9 scale degrees and completely covered the entire NEP wide field, as shown here in red colors. And also SCUBA 2, 850 micron mapping is still going on. So last month they reported that this area, observation over this area is finished. So originally 400 hours assigned to 21 target fields, but now more than 30% is completed. So this dotted line shows the NEP deep field where the S2CLS data are available. So and this red color, thick red colored circle shows that the observations were finished in order of the number written inside the circle. So from target field number 1 to 6, and then they move to the target 7. And we also have a spectroscopic redshift data for more than 3,000 sources. So most of them are classified into star-forming galaxies and AGN types, but some of them are not classified into any types, and some of them are strange labels. So this spectroscopic catalog we have now is compiled by Miyaji-san, but he's not attending this year. But instead we have Matt and Toshi and Seong-Jin here. So I think this is a very good chance to ask some questions if you have something to say. So the first step about band merging was matching between the Akari and HSC. So this is kind of a distribution of astrometry offset based on the 74 sources matched based on the 3 per second ranges. So this is from the previous results carried out by NISA, and the matching status looks good. So based on this, we carried out these procedures. So this schematic diagram shows actually what I have been doing so far, but it looks quite simple and easy, right? But actually, it was a little bit complicated because if there is we found some issues and problems, we have to go back to the previous stage and we have to update and renew the color. So this sounds quite tedious and annoying job, right? But this is really important because this band merged color can be of starting point of many science projects. So as you see, we're going to get more band merged data for more than 40 photometric bands in total, from U band to the Spire 500. So for example, we found that there is a little bit offset between the HSC and the previous optical data. So we fixed the offset and try to apply the 3 sigma radius and carry the matching. But besides that, the other parts looks nice. For example, the astrometry comparison against the WISE data looks good. So 3 sigma radius is quite small. And for example, another example, photometry against the speech data looks good as long as we use automated tool. So this is kind of previous results. When we match against HAC coordinates, so when we use this kind of 3 sigma radius, this is kind of a number of sources matched to the HAC data. But a few weeks ago, we decided to change some part of the matching procedure because this kind of matching radius is kind of a little bit too strict when we match mid-infrared data. So when we match optical data, we don't need to care too much about the previous results. But when we match near-infrared data, for example, speech-wise or Mariana data, we need to match with occurring near-infrared coordinates. And when we match Herschel data, we need to match with the mid-infrared, occurring mid-infrared coordinates. Also we need to include all the Akari sources because previous catalog in 2012 doesn't have Akari sources newly identified by the HSC data. So Nagisa found this. So we need to decide to use all the Akari sources detected at least in one Akari band. So maybe next week or in 2 weeks, maybe I think we can show you the final version of band music. So that's all from me today.
Is that microphone working or not?
If you're sitting here,
It does work?
yeah,
It works?
here, you see it.
It does work.
I think so.
So people in the audience can use this for questions?
Not.
So if you have a question, you should be very loud so people can hear it online. You guys are very shy in the morning. I have a question. Could you go back to first slide, or this shows the tracts, colored tracts. It's all near the beginning. So I assume that the sensitivity in each of those tracts is approximately there. So it's approximately similar sensitivity in each of these tracks. But of course, the sensitivity where they overlap is significantly deeper. Yeah, that's right. Like almost a magnitude, maybe deeper.
I didn't take the exact number how much amount to deeper, but yes, you're right that the NEP deep field,
It's in the middle there.
yeah, around there, we observe there twice as much as the other field.
Well, if it's twice as much, then that would only be about a half a magnitude at best.
Maybe, but deeper than the other field.
Yeah, so it is deeper here, but not incredibly deeper. And then some of them overlap a little bit. I mean, the sensitivity is really not the same anywhere on this. It just varies a a lot. My other question was, I know it's difficult, but you have experience with large beam PSF. So what about the possibility, Dennis, listening to this, about band merging the Galax UV photometry?
For now, I don't have any plan to include UV or radio. So I think
radio
this
also.
is the first, and maybe.
Okay, this is already a heroic amount of work which everyone is going to benefit from. I mean, it's incredible. Other question?
Yeah, please a few comments. So we definitely should merge galaxies because we have, new band, right? So, I mean, we should do best for band.
Right, U-band gives a good prediction
and
of the Galax.
That's one point. Then another point is there's a little bit of big change you noticed that Seong-Jin said, right? So previously, we are requiring detection in 2 Akari bands to be in a catalog. But now we are including 1 band only detection, right?
Which is usually 4 micron and 4.
Is it 4 micron or millimeter?
Most common.
Yeah, at all band. So we include actually all the
Anything.
Anything.
Can
Right.
show that this is high charge.
Right, but I
So-
mean, when you detect with only 1 filter, I mean, unless it's an asteroid or something at 9 microns, I expect it would be 4 micron.
So we're going to include all the Akari source, and I think we need to include also NEP source
Yes,
in the
yes.
end, right?
So there will be about 100 some sources going to be added to the master catalog now. So that might or might not affect your science. So please be careful about this change.
100?
Yeah, how much is in that also?
So this part may
Now
be
catalog is getting a little bit, so in a blue part, how many sources?
135,000.
Right, so it's 20,000 more in the blue.
Oh, okay. So this is not 100. Something like that, yeah.
So next so you will next Nagisa will be the details of that.
So this is also a discussion item. So we want to hear your opinions. I mean, what you want on our master catalog. Because this catalog Seong-Jin is making is going to be master catalog for everyone to use. Please give us your opinion. Okay, that's all. Thank you.